Let's consider a function f of x is equal to x minus 4 and try to understand what do we mean by inverse of this function. We know that the domain of function is the set of values that it can take as an input, and range of any function is the set of values that it can output. So for this function f of x is equal to x minus 4, we can see that for x is equal to -1, we get -5 as an output. For x is equal to 0, we get -4. For x is equal to 1, we get -3. For x is equal to 2, we get -2, and so on. Now, let's try to understand what do we mean by inverse of this function and what is the inverse function going to do. So, let's give the heading inverse. And as the name suggests, inverse, it's going to do exactly opposite of what f of x does or our original function does. So we know that our original function maps the value in its domain to the values in the range set. But this inverse function, as we can guess, is going to map the values from the range set to the domain set. That's what inverse means. That means the domain of this inverse function is going to be the range of our original function. So let me just copy this and paste it over there. So we know that the range of our original function is now going to be the domain. So -5, -4, -3, -2, and so on. So this is our new domain. Let me write it over here. Now the range of this inverse function is going to be the domain of our original function. So let's just copy and paste it once again, and we keep it over here. So the domain of our original function is now the range, and the values are -1, 0, 1, and 2. So this new inverse function should map -5 to -1, -4 to 0, -3 to 1, and -2 to 2. So exactly opposite of what f of x does. So let's try to see and let's try to understand how does that function look. So to write the inverse of any function, so let's consider our original function. So our original function is, let's write it as y is equal to x minus 4. So I just write y instead of f of x. Now to write the inverse of this function, what we can do is, since this inverse function is mapping the range of our original function to its domain, that means the x values are now going to be the outputs and the y values are now going to be the inputs. So we can write this original function, we can rewrite it and make x the subject. So x is equal to y plus 4. What I just did is I just sent this 4 on the left hand side and the sign changes. So this is the new function, and it is written in terms of y now and making x the subject. So we can say that this is a function of y, which is y plus 4, where f of y is actually x. X is a function of y now. And we already know that for any function, we can use any letters, and let's try to rewrite this in terms of x. So f of x is equal to x plus 4. This is our inverse function, and it's written something like this: f inverse of x is equal to x plus 4. Let's try to see if it does what we expect it to do. So let's try to see if it maps the domain to its range. And by the way, this domain is actually the range of our original function, and this range is actually the domain of our original function. So maybe I can rename it as new domain and new range. So let's see. For x is equal to -5, if I substitute -5, f of -5 is -5 plus 4, and that is -1. So we can see that, yeah, it's doing its job. For f of -4, we get -4 plus 4, which is equal to 0. And that's correct. For -3, we can see that -3 plus 4 is going to be 1. For -2, -2 plus 4 is going to be 2. So indeed, we can see that this inverse function does exactly opposite of what our new original function does. It maps the range of our original function to its domain, and the range of our original function becomes the new domain of our inverse function. Now let's try to understand it graphically. As you can see, this is y is equal to x minus 4, or our original function. And this is y is equal to x plus 4, or the inverse. Let's try to examine some points. Let's try to examine these functions at some points. So our original function at x is equal to 4 outputs 0. So at x is equal to 4, it outputs 0. What our new function, the inverse function, should do is that at 0, it should give you 4. So because our original function, what it does is at x is equal to 4, it gives you 0. So at 0, the inverse function should give you 4. So if we substitute 0 over here, we get 0 plus 4, which is 4. So as we can see, at 0, it gives us 4. Let's say at x is equal to 2. At x is equal to 2, our original function gives us -2. So at x is equal to -2, our inverse function should give us 2. So as we can see, at x is equal to -2, our inverse function gives us 2. Let's say at x is equal to 0. At x is equal to 0, our original function gives us -4. So at -4, our inverse function should give us 0, which is correct. And as we can see, as it's clear from this graph, that the inverse function and the original function, so the inverse function is actually reflected about y is equal to x, is reflected about y is equal to x.